Hello, I'm Namita Shah and I'm a 6th semester Electronics and Instrumentation student. My sub-study group comprises Shriya, Ismail, Soundarya and myself. Our topic is DC motor speed control by NI dashboard using myRIO and Labview. A DC motor, it is a class of rotary electrical machines which convert direct electrical power to mechanical power. Speed of DC motor can vary from wide range either by supply voltage or by changing the strength of current in its field. A simple DC motor naturally has a fixed set of magnets in a stator and an armature with ending on a commutator. The purpose of commutator is to convert the alternating current to direct current. Laboratory Virtual Instrument Engineering Workbench, also known as Labview, uses G programming or graphical programming. Labview is universally created for data acquisition, industrial automation, and robotics. NI myRIO provides the powerful hardware and software technology along with Wi-Fi connectivity. The NI dashboard allows to create custom codes using Labview applications. This project describes the interfacing of DC motor with NI Labview with the help of NI myRIO, and this is controlled by NI dashboard.
The motivation of the project is the DC motor being widely used component, making it more simple and so that it can be sophisticatedly used. If the control unit is placed elsewhere away from the mechanical parts, it is possible to control it using the NI dashboard in order to make the control action easy and flexible. This is the literature survey. These are the papers we referred for the information being put in. Paper 1, International Journal of Electrical, Electronics and Computer Science. The detection methodology is speed and direction control of DC motor using Android mobile application. The advantages being the Bluetooth consuming less power than the other devices. Android application is user friendly, but it also has its own disadvantages. The disadvantages being that usage of Bluetooth module makes the usage only with a short range, and using of Android app in smartphones consumes battery. The second paper we referred was International Journals of Innovative Research in Science, Engineering and Technology, and the detection methodology being Arduino-based speed control of DC motor by using Labview. In this method, the advantages being the absence of rheostatic control, hence power loss is negotiable. We can control many motors via central Arduino. And the disadvantages being the circuit is being complex, the method requires more time to run the DC motor.
Hi, I am Soundarya. Today I am explaining about the methodology of the DC motor control using NI data dashboard through the myRIO. The aim of the DC motor control using NI data dashboard through the myRIO is controlling the speed or position of the DC motor using NI data dashboard, because if the control unit is placed elsewhere away from the mechanical parts, it is possible to control it is using the NI data dashboard parts. It is in order to make control actions easy and flexible. Using the Labview software, open the Labview software and create the new project. Create the two shared variable for interface between the myRIO and NI data dashboard. One shared variable for control the input of DC motor and second one for the indicating the output of the DC motor. Next, connect the myRIO to DC motor and then save the project. After this, create the new VI, write the Labview program of the DC motor on the block diagram and connect the shared variables. Deploy the project. During the deploying, IP address will create it for connecting the dashboards and myRIO. Then click on run button in dashboard. DC motor is start running and this output waveform is showing on the data dashboard. This system is consist of the functional devices. First one is Labview software and the DC motor, myRIO and NI data dashboard installed. Next, the Labview. The Labview is Laboratory Virtual Instrument Engineering Workbench. This system design platform, and this is developed for virtual programming language. This is developed by or created by the National Instrument. It allows the instrument control, data acquisitions, processing of the acquired. The Labview consists of graphical symbols for describing the programming actions. The Labview programs are called as virtual instrument. It consists of three main parts. First of all, the front panel. It consists of only the indicator and control. In this part, nothing happened. The connecting actions in the block diagram. This is the second main part of the VI. It shows the connections of the one part to another part, and the third one is a connector pane. This shows the method of connections in the VI. The DC motor. The DC motor is one of the hardware components in our project. The DC motor is an electrical machine. It converts the electrical energy into mechanical energy. The main principle behind working a DC motor is the electromagnetic law, according to which a current carrying conductor placed in the magnetic field experiences a force, and the directions of the force is given by Fleming left-hand rule. In order to understand the basic principles, we need to understand basic constructional features of a DC motor. Every DC motor contains 6 parts: axles, rotor, commutator, and field magnetic and brushes. The basic component of the DC motor is current carrying armature, which is connected to the supply end through the commutator segment, and brushes. The armature is placed between two permanent magnet which produce a magnetic field. The applied directions current converts the electrical energy into the mechanical energy. Because of the interactions of two magnetic fields, one field is produced by the permanent magnet and the other is produced by the electrical current flowing through the armature winding. Because of the interactions of the two fields, the armature experiences a force which tends to rotate the motor. This is how a DC motor works. There are 3 types of DC motors. One is a shunt, and second one is series, and is a compound DC motors. And the myRIO. The myRIO is a real-time embedded evaluation board made by the National Instrument. It is used to develop the application that utilize in the board, FPGA and microprocessor. It requires a Labview. It's geared towards student and the basic applications. The RIO stands for Reconfigurable Input and Output and describe the technology used in many NI hardware products. The RIO products features its processors and the FPGA, the both of which are fully programmable using NI Labview software. This is the myRIO device, and this is the motor adapter for NI myRIO. This is used for taking or damp the input to the DC motor at current carrying or taking the outputs of the DC motors. This is the actual program we done in this project. The specification of myRIO. This is Xilinx ZYNQ 7010 processor, 667 MHz. The ARM Cortex A9 into the 2 cores, 28 nanometer, and the non-volatile memory. The non-volatile memory consists of 256 MB and DDR3 is a 512 MB and 533 MHz of Wi-Fi wireless network, and this is a 16 bits. And then this is the universal asynchronous receiver and transmitter, the digital input output pins. These are 16 IO lines. This having the analog output is having the 2 IO lines, and the analog input having the 4 IO lines. The processor Labview RT and FPGA Labview FPGA. This is the, and it consists of the accelerometer and button 0. the accelerometers, these acts as accelerometers. The two ports of digital I/O pins I already told, and then the I/O pins already, and AO. This is a two I/O ports. This AA also two I/O ports. It having the voltage. It supply the voltage minus 15 volts and plus 15 volts. It consume the power max. It consume the maximum power is 14 volts. The typical ideal power is 2.16 watts. The maximum power consumption is 14 watt. And then this is a watchdog and wireless button and status LED and wireless LED and user LED. The FPGA type same as processor. The wireless network is IEEE 802.11 BG and ISM 2.4 GHz 20 MHz. Finally, the NI data dashboard. The NI data dashboard is the main controlling part in our project. The NI data dashboards allows you to create the custom and portable views of a National Instrument Labview application. Using this application, you can create data dashboard to display the values of network, published shaded variables, and deploy the Labview web services on the indicators such as the charts, gauge, text boxes and LEDs. The data dashboards is available for Apple iPod and Android tablet in the iTunes and the Google Play stores. In this project, we use an NI data dashboard for controlling the DC motor through the Labview and myRIO using the shaded variables and web services. This controlled by values, and it shows the output of the DC motors like waveforms and values or visual representations. NI data dashboard steps: creating a data dashboard and deploying the shaded variables after writing the program on the block diagram of VIs, connecting to the shaded variables to the myRIO and the data dashboard, and deploying the web services in Labview 2018 or 2015, whatever it may be, connecting to the web service and additional resources. And the block diagram. This is the actual block diagram of the DC motor control using NI data dashboard through the myRIO. We're using the Labview. It's having some benefits. This is extensive interface, code reuse, and platform independent. These are the benefits of the Labview. And then applications of Labview is the parallel processing and machine control and monitoring and research and analysis and controlling the designs. myRIO. The myRIO has dual-core ARM Cortex A9 programmable processor. The FPGA supports in myRIO helps the student to design real-life developing system and solve the real problem quite faster as compared to the other microcontroller. Using FPGA supports, we can avoid the complicated syntax used in C language and in my other languages. The DC motor. It is used for mechanical actions, reactions and all. It is used for convert the electrical energy into mechanical energy, and this having some applications. It is used in cranes and conveyors and pumps, cars, and mixer and grinders and air compressor and toys, some military applications. And finally, the block diagram is doing, the Labview is create the shaded variables, and after deploying the DC motor program on the block diagram, it is give some IP address for connecting the data dashboards and myRIO, and after the data dashboard control the actions of the DC motor and shows the waveform output of the DC motor on the data dashboard installed iPad. This is the working of our project.
So the application part is the application of DC motor in the field of mechanical hardware, and which includes the mechanical operated machines. So few of the applications are lathe machines, centrifugal pumps, conveyors, weaving and spinning machines, drilling and milling machine. So the next slide is expected results. As the expected result, the speed of the DC motor is controlled as per the requirement and as per the required specification by the industry. The position of motor can also be controlled by an angle of turn. What angle the motor turns to the position itself by an angle can be decided by the user change accordingly, which is displayed on the NI dashboard and gives the opportunity for the control. So the next slide is references. So here are some of the few of the references. MD Salim Reza, MD Abdullah Al Alam, design and development of Labview based DC motor speed and direction control system. So Pratap VK, Neelam Punjabi, Chandrakant Kadu, real time DC motor control PID control Labview, Olden P, open loop motor control and the Labview, Southern Come, proceeding IEEE, EA Coity Haldi, microprocessor based on closed loops, speed controller based on the DC motor using a power MOSFET, IEEE, International Conference of Electronics Circuits and Systems, Chandraboti S. Kumar, and analysis of external content plagisting using the character swan or optimization, stability, smart computing and informatics based innovation system and technologies. So yes, Muruganathan, real-time DC motor speed control using PID controller and LabView. Pratap VK, real-time DC motor speed control PID controller. So here are some of the websites: www.theengineersproject.com and Raj Thakur, Kamlesh Kodan, Raj Kodse, Dilip Odesa, monitoring of electrical and industry. Thank you.
Linked to the individual subjects are as follows: virtual instrumentation using Labview, myRIO and Labview software. For automatic process control and modeling techniques, DC motor speed control. For CCN or Java, NI data dashboard.